VHDL is a language for describing the behavior and structure of electronic circuits. VHDL is intended for circuit synthesis as well as circuit simulation. However, though VHDL is fully simulatable, not all constructs are synthesizable. The letters VHDL stand for the VSIC, Very High Speed Integrated Circuit, Hardware Description Language. VHDL source code is usually typed into a text file on a computer. That text file is then submitted to a VHDL compiler which builds the data files necessary for simulation or synthesis. Fundamental sections of a basic VHDL code: library declarations, entity, and architecture. Library declarations contains a list of all libraries to be used in the design. Entity specifies the I/O pins of the circuit. Architecture contains the VHDL code proper, which describes how the circuit should behave. We use Xilinx's ISE suite for writing the VHDL code and simulation or synthesis. Run ISE Design Suite 14.7. Select New Project. Select a name and specify a storage location. We want to use the hardware description language. If you are using a particular board, you can select it from this list. If you follow the properties strategy exist in this list, you can select it. Select the chip from here. Select VHDL description language. Click the Finish. The project is created. Now, you need to create the source file. Select the VHDL module. Enter the file name, which will also be the name of the entity. The source file consists of three main parts: library, entity, and architecture. In the entity, inputs and outputs are defined as study logic. Architecture has two parts: a declarative part, optional, where signals and constants, among others, are declared, and the body part, from begin down. In architecture, describe the behavior of the circuit. Run XST. The project has no errors. You can create a test bench file. Select the VHDL test bench. Enter a name. Specify the entity under test. The test bench has a structure similar to a source file. In the architecture section, was declared the component first. Signal for connecting inputs and outputs. Clock period. How to connect the ports is specified. Clock generator process. Stimulus process. Stimulate the inputs in the order you want. For example, go to the Simulation tab and select the test bench. Start the simulation step. Simulation result. The inputs and outputs of the described circuit correspond to the behavior of the NOT gate. You can see the schematic of the circuit. Input buffer. Output buffer. NOT gate or inverter. If you are interested in the topics of this channel, do not forget to subscribe. Thanks for watching.